Welcome back. So we now have our bot pawn. We're possessing it. We can see from the point of view of the camera component, and we even have an input mapping context added, and we can respond to the activation of the input action IA fire. Now, what I'd like to happen is for our bot pawn to fire a blaster beam whenever we press on one of the inputs that we've linked up to this input action. In my case, I've linked up the left mouse button and the F key to IA fire. So whenever I press one of these, I'd like to fire a blaster beam. So that's the goal. And in addition to that, every time I fire, I'd like to alternate between left and right rifles, just like our bot actor does. So this is going to be a challenge for you. For this challenge, I'd like you to set up firing the rifle in response to the input action IA fire. Every time we click that left mouse button or press the F key, I'd like to see one of the rifles fire a blaster beam. And preferably, I'd like those blaster beams to alternate between left and right rifles. Now, see if you can do this without going into the BP bot actor blueprint to see how we fired blaster beams before. But if you get stuck, take a look at that class to remind yourself how you can spawn blaster beams. Pause the video and tackle this challenge now. Okay, so I have several execution pins to think about. I know that triggered will be executed every frame as long as my input is held down, whereas started will fire off once per button press. So that's what I want. And much like we did in BP bot, I'd like a handy function that can do that. So I'm going to add a new function by clicking add, going to function, and I'm going to call this fire rifle. Now this could be a name, but I'd like fire rifle to handle the names for the socket. I'm just going to add a Boolean variable here called isLeftRifle. It'll be true if we're firing the left rifle, and false means we'll be firing the right rifle. And here in fire rifle, we're going to get a socket location. So I'm going to call get socket location and choose the one with bot mesh. That way we'll be calling it on the bot mesh itself. And if I'd like to go back to my bot to see what the socket names are, I can click on my bot mesh, find that static mesh SM drone, and browse to it and open that up and take a look at my sockets. They're called rifle_L and rifle_R. So here's what I'm going to do. Here inside fire rifle, I'm going to place a branch. And I'm going to check if isLeftRifle is true. And if it is, I'm going to create a brand new local variable. A variable local to this function. It doesn't exist outside the function. It gets created when the function is called. So I can go to variables, create a new one, call it socket name, change its type to name, and set socket name to rifle_L. And I'm going to duplicate this setter and set it to rifle_R. In this one, that'll be in the false case. So if isLeftRifle is true, this local socket name variable will be set to rifle_L, otherwise it's set to rifle_R. Next, what I can do is I can spawn an actor. I'm going to call spawn actor from class, and for the class, I'm going to choose BP blaster beam. And both of these set nodes are going to hook in to this spawn actor node. And I can right-click spawn transform, split the struct pin, and use the result of get socket location here. I can also get socket rotation. So get socket rotation. I can do that and hook that in for the rotation. And if I didn't want 2 nodes, I can have a more compact version of this by calling get socket transform. And I can right click the return value, split the struct pin, and simply plug in location and rotation. And in fact, if I'm going to do that, I can just recombine the struct pin on both of these and simply plug in the transform itself. Now I need to specify a socket name. I'm going to use the socket name local variable here. So local variables are nice because they don't exist on the actor itself. They exist locally within a function. They're created and destroyed within the scope of that function, which is nice. So now I can call fire rifle, passing in a Boolean, true or false. True means we'll fire the left rifle. False means we'll fire the right rifle. So we can test this out. I'm going to go back to the event graph and call this function fire rifle on started. And I'm going to pass in true and see if we can fire the left rifle. Let's play test. I'm going to left click, and there it goes. We fired the left rifle. Now we want alternating behavior, right? And that's what the flip-flop is good for. So I can right click, type flip-flop, hook that up to started, and hook A up to fire rifle. And I can duplicate fire rifle, hook it up to B, and I can uncheck is left rifle here. And if we play test this, we expect to see alternating rifles. Let's check it out. Left, right, left, right. Perfect. Okay, now you may be thinking, well, flip-flop returns a Boolean that says is A. This should be true every other time and false every other time, shouldn't it? So theoretically, we should be able to just get rid of one of these function calls and hook both A and B up to fire rifle and simply pass is A in for is left rifle. Would this work? Let's check it out. Let's press play and fire. And look at that. We're alternating. So it does work. That allows us to have one less node and things look a lot cleaner. Okay, so that was the challenge. And if we like, we can add more things to this function, such as spawning particles and sounds as well. Now for this, I'm just going to go straight over to my drone folder and open BP bot and open spawn blaster beam and steal a couple of nodes here. We're going to steal spawn system at location and play sound at location. I'm just going to copy these nodes and come back to BP bot pawn here in fire rifle and paste them in. Now, the interesting thing is that in BP bot, we had socket name, right? Which was a input parameter to this function. This is kind of like a local variable. It's local within the scope of the function. It doesn't exist outside of it. When I created a local variable in fire rifle, I created a variable that's local to the function like that, but it's not an input parameter. That's the only difference. But because the variable socket name exists within this function, I can paste that node in and it just links up and it uses socket name. Pretty convenient. So I can hook these up and we can play test this. All right, excellent. And we can fire our rifle. This is looking great. Now you may be tempted to hook this up to triggered as well and see what happens if we simply hold the mouse button down. Well, that's going to fire every frame, which is way too fast. Watch. Yeah, way too fast. However, if you did want to be able to hold that input down, there's a special thing that exists in the enhanced input system. If we go to IMC bot and take a look at our input mapping context here, we'll see that each of these input actions has triggers and modifiers. These are arrays. They're empty, but these allow us to change behavior for inputs. Modifiers affect the value of our input action after they've been triggered. Our value in the case of IA fire is a Boolean value. We don't want to change that. Triggers, however, allow us to affect the way an input action can be activated or triggered. Let's add a new trigger by clicking plus, and from the dropdown we can choose from any number of these built-in triggers, and the one I'm interested in is called pulse. This allows us to throttle that triggered execution pin. Let's choose pulse and expand this index, and we have some options. This is going to make our trigger activate every so often according to the interval. The interval is set to 1, and this is in seconds, but I'm going to set it to 0.25, and I'm going to leave trigger on start checked. Now if we go back to BotPawn, I'm going to disconnect the started pin and leave this on triggered and see what happens if I hold my mouse button down. Now we're triggering every 0.25 seconds, and I can lower that to 0.1 if I want faster behavior. So the pulse trigger is going to throttle that. However, I only added it to left mouse button, so if I go back and I press the F key, well, that's still going way too fast. Now I have the option to add this same trigger and configure the same settings for it to the F input action. But if I want them all affected by this pulse trigger, well, I can add them directly to the IA fire input action. So we're going to do that. I'm going to remove the trigger from here in the input mapping context with the trash can icon, and I'm going to go into IA fire, which has its own triggers array. I'm going to add one. I'm going to choose pulse, and I'm going to expand it and change the interval to 0.1, like so. And now if I play test, I can try holding down the mouse button, and that works. And I can try holding down the F key, and that too works. And now we have automatic fire. Excellent. 0.1 seconds might be too fast, but I can always adjust it. I'll set it to 0.15. All right. So we now have firing behavior for our BotPawn. This is looking great. We now need to figure out how we can actually make our BotPawn fly around. That'll be next. I'll see you soon.